thank you very much for being here, everyone. It's super exciting for us to, well, it's our second live DuckDB, actually in much shorter succession than we would have thought. The last one was 4 months ago in Brussels. We thought this was going to be a yearly thing, but apparently, well, we just like doing it so much and people like going somehow. So that's, it's excellent to be here again. Yeah, so I'm going to give a bit of an update. It's something of a common theme we've done. I mean, common, there's been 3 DuckCons. We've done 3 State of the Ducks. That's why there's a V3 there. And just kind of a bit of an overview of what we have been working on, what we're planning, and also a bit of like a Q&A for people that want to potentially ask any questions. I mean, that's also why we're here, to talk with you guys and get your perspective on things. So yeah, State of the Duck, the second one. I'm going to give like a bit of a overview of what we have done in the past 4 months, I think, since the last DuckCon. So it's not as exhaustive as the previous one, where we could talk about like a whole year. As I said, these things are increasing, they're occurring more and more frequently. So it's actually not the last year in DuckDB, it's the last 4 months in DuckDB. I'm going to give a bit of a sneak preview on what we're working on and planning for the next version, so version 0.9. And I'm going to talk a bit about adoption as well, and just going to do a bit of a Q&A. So any questions that you have, I'd also be very happy to answer and talk about. All right, so last 4 months of DuckDB. Well, we had 2 releases. The first release, version 0.7, was actually, I think, 1 day after the last DuckCon. That was not a coincidence. We had planned that as well, of course. And this version had some very cool features. It had the attach and multi-database support. So that's something that SQLite has as well. And it's kind of cool because you can attach multiple DuckDB databases to a single instance. And I think something that's super cool about the way we've done it is that it's you can create your own database type. So it's actually like a pluggable database architecture. And that means that not only can you attach more DuckDB database to your DuckDB database, which can enable you to, well, load data from multiple DuckDB databases, or copy over data from one to the other, you can also define your own database storage in different extensions if you are so inclined. And one of the ones we have worked on is the SQLite storage backend. So you can actually use the SQLite plugin that we have to attach SQLite databases directly. And that means that you can not only just read SQLite databases, you can create tables in them, you can insert data, you can delete data, update data, and it's all like nicely transactional, and it all works pretty nicely. And it also means you can run using DuckDB SQL dialect over SQLite databases, and it's quite fast as well. So I think that's quite cool. So if you haven't seen or tried that yet, I can recommend giving it a go. And of course, if you're so inclined, if you're more adventurous, let's say, you can also define your own database formats using our extension ecosystem. Cool. I think this is one of the features that has been very long awaited, that was also very well received. It was the JSON reading. So in version 0.7, we introduced parallel JSON reading and auto detection for JSON. You may be thinking, why do you need auto detection for JSON? Well, there's actually different types of JSON somehow. They have the new line delimited JSON, which is kind of the easiest one to read, but you also have things like area of records. You also just have like one big JSON key value object. And Lawrence on our team has done a very good job on making our JSON plugin essentially as easy to use as possible, right? It's something that we always try to do, is try to make things easy to use so that, well, you don't bother us. You don't ask any questions to us, so we could just like leave you to work with this stuff yourself. And it's also quite fast. So here's an example of how this works. You can just point out the JSON. I think probably most of you have seen or used this. It was quite well received, I think, and very well used. Another cool thing that we added in version 0.7 was write support for high partition files. So for those that aren't familiar with high partitioning, it's like this kind of partitioning structure where the partitioning information is defined in the file, in like the folder structure of the file. And it's not the most efficient partitioning scheme, but it is probably the easiest one. Like, it's very easy to manually inspect and create these partitions. However, in order to have like a very efficient write to these files, it's not actually that easy, because you end up creating tons of files and doing like a sort of efficient streaming write so that you don't run out of memory. that was ended up being somewhat challenging. And using the new high partition write, that's exactly possible. So if you write to like Parquet files, you can specify this partition by clause, and it will actually do the partitioning of the data and write to this structure. So if you have any sort of big data sets that you think will benefit from partitioning, you can use this. And then, of course, DuckDB has already had support for reading these types of partitions for a long time. So that's also something that is, very cool, and enables efficient querying of large data sets over partition data. We also had a bunch of new SQL features. Well, some new as in we actually made them up, like the positional join one, which was implemented by Richard here, which is quite interesting. And some new as in we didn't have them before and we implemented it. So I think one of the ones that was quite, that a lot of people were excited about was the upserts. So that essentially allows you to insert or replace data. And it's kind of an easy way of working with data that has like a primary key constraint. The lateral joins, I could give a whole talk on lateral joins. If you essentially, well, maybe I shouldn't get started on that. Okay, a lateral join, it's a bit like a more advanced correlated subquery. If you aren't familiar with the correlated subquery, I have actually recently written a blog post on that on the DuckDB website, so you can read up on it. And it's kind of one of those things that it's deceptively powerful. Like you can do a lot of very cool things with lateral joins. It's essentially a bit like defining a function at runtime that runs on a table. It's quite cool. And I think Lloyd, who's going to talk later, he has made some quite good use of these lateral joins. The positional joins, I think this is something that's quite interesting because in SQL generally, you don't really have there is no well-defined concept of an order, right? Like you have rows, but in principle, SQL defines these as just being like a bag of rows, right? There's no fixed order. But in DuckDB, we do try quite hard to maintain the order as specified by the user, as well, because that's what a lot of other data frame libraries do, like things like Pandas, R data frames. They all kind of maintain this order, and it's something that ends up being quite useful also in things like ML workloads, and something that's the positional join builds on top of. So the positional join, what it does, well, it's a bit in the name, it joins on position. So instead of having a join predicate where you say, I want to join based on the value of a column, you say, I want to join row 1 with row 1 in the other table. And that's something that if you have maintained this order, turns out to be quite useful to easily combine these different joins. And that's something that isn't in SQL, of course, because SQL doesn't have a concept of order of rows, but is now in DuckDB. So if you haven't seen that yet, that's I encourage you to check that out as well. After that, we had version 0.8, May 17, around a month ago. And then we had some very cool features as well. I think something that a lot of people have been excited about, and me as well, is the pivot feature. So pivot, for those that aren't familiar, it comes from this Excel pivot table thing. And kind of the core idea behind pivot and the corollary unpivot is that you turn columns into rows and rows into columns. So you have this sort of like transformation. And the reason that's useful is that in practice, quite a lot of data sets encode information or like data in their actual columns. And it turns out that that's not easy to work with in SQL because SQL is based, of course, on rows. Like everything is centered around rows. You can do group by, you can filter on rows, all that good stuff. But you can't you can't filter on columns very easily. And what pivot and unpivot allow you to do is they allow you to convert between the two, which allows you to then do operations on those columns as if they were rows. So here's an example. If you can see this table on the left, you can pivot on the year, which then turns the rows, the years, into columns in the new table. And for this, there is a SQL standard syntax, but we have also kind of invented our own syntax that is a bit more readable, that we have worked on together with some data engineers. And that's kind of like, because it's it actually turns out to be quite a common operation, depending on the type of data that you work with. It's nice to have kind of a shorthand that's a bit more easy to work with. So you have pivot and you have unpivot. That's kind of the opposite, right? So pivot turns rows into columns. Unpivot turns columns into rows. Both of those are, very useful depending on which data sets you're working with. Another cool feature that we had in 0.8 was the as of joins. So this is essentially, it's a fuzzy type of join that's mostly useful for time series data sets. So the idea behind an as-of join is that if you have two different sets of time series data that are maybe not entirely overlapping, right? Like maybe in this, for example, this example that I have here, you have on the left, you have 1031, and on the right, you have 1030, right? So they're close, but not entirely overlapping. You often end up wanting to join on kind of like the closest match. And that's what this join allows you to do very efficiently, is it allows you to find essentially the row in the right table that's like right below the row in the left table. And that is very useful if you are joining like large time series data sets or sensor data or things like that that are marked by time series together. And this is also something that Richard has implemented, and it's very cool. So if you haven't seen that yet, check it out as well. It's also in our documentation, of course. We've also worked quite hard on parallel data export. So in version 0.7, we added parallel data export for non-order preserving data. So the order preserving thing, that's something that's I had alluded to before as well with the row positions, right? Because we try to preserve the order, there is some added complication there when you try to write things out to a CSV, to a Parquet, or to a JSON file. And that's something that has arrived in version 0.8 as well, is that we can do parallel writes to these formats while preserving the insertion order, like the order that we have ingested in. So that greatly speeds up the copy to using the default settings. And that's something that we care about a lot because we, of course, want to try, like, we want the default path to be as usable, as fast as possible, and as nice as possible. So that's now much improved as well since version 0.8. And we have had the spatial extension release. So that's something that Mux has worked on extensively, and something that's very cool that allows you to do, well, spatial operations. So if you have a need for this, that's kind of something that's, it's in a sense, it's kind of this world on its own. I'm not too familiar with it. Mux is the local expert. But if you want to do things like anything involving maps, coordinate systems, things like that, you end up wanting a lot of these sort of like similar operations, reading these sort of files, doing like spatial joins and things like that. And since version 0.8, a little bit before, we have now a spatial extension that can allow you to do all these things and also allow you to interface with all of the geom formats, like using this GDAL library. And something that's actually kind of funny that we discovered later is this GDAL library also allows you to read Excel files. So through the spatial extension, you can now read Excel files. That was not intentional, but it just kind of happened. So we just figured it out. We're like, yeah, okay, that's actually useful. So there you go. So if you want to read Excel files, you can also look at the spatial extension. There's actually a guide on our website. I think Alex wrote it. Yeah, so that's very cool. All right, so a little bit of a sneak preview of what we're working on, and it's very sneaky because this is actually a goose, not a duck. Just like a bit of a sort of short overview. It's not complete, but just what I think are probably some of the most exciting features that we are developing. I think something that people have asked for a lot and that we think is very important is the out-of-core support in general, but specifically the out-of-core hash aggregate. So for those that aren't familiar with out-of-core, essentially what we mean by that is that if you have a data set that exceeds memory, or you have intermediates that exceed memory, at some point you need to do something clever to make sure that you can operate the data set. And because people are wrangling quite large data sets with DuckDB on often very small machines, I mean, that's also what we tell you to do, so that's not that's not your fault, of course. But there is often the case where you could have fixed, your computer in principle has enough sort of overall storage space, right? Like SSD space plus memory to complete the operation. But because there are like these memory constraints on things like hash tables, you end up running into an out-of-memory exception. And something we have been working quite hard on improving. We have started with the order by that has had support for this for a while. The join has support for this. The window operator has support for this. And with version 0.9, we're going to have support for this in the out-of-core hash aggregate. And what that means is that, of course, DuckDB has a streaming engine. So in principle, if you have a like an aggregate with a small number of groups, it will work even if your data set is extremely large. But if the hash table that's used during the group by is very large, currently that does not work because we require the whole hash table to fit in memory. And that can happen if you are, for example, running a distinct on a lot of rows, or if you are running a group by with many rows, with many unique groups, right? And so we have been working on this. Laurens has been working on this, and it's very cool. The way that it's done is that because hash tables, it's kind of something that doesn't naturally lend itself to being out of core, because the hash tables, they mostly work with like pointers, right? However, we have a very awesome hash table that has been made by Hannes, actually, and that does a radix partitioning. Oh, am I out of time? Oh, excellent. Very good, very good. We have a hash table that uses radix partitioning that actually does not create one big hash table, but a lot of much smaller ones. And essentially, by cleverly looking at how much memory is required, by like looking at how these hash tables are being created, how much memory is consumed, and looking at the available memory, we can do something that's quite clever, where we try to keep this stuff in memory as long as possible. But if we end up in a situation where you run out of memory, we can slowly start spilling to disk. And that's something that has the very cool result that you get this super graceful degradation, so that even if your hash table, if it's say 80% of the hash table fits in memory, you won't end up with a big performance penalty, and we'll try to make as much use of your memory as possible, all the way towards where almost none of your hash table fits in memory, and then of course you end up with a lot of I/O. So yeah, that's something that's going to be very cool, and that's hopefully going to help people, help you guys process even bigger data sets with DuckDB. Something that's kind of in a similar vein that we're working on is compressed materialization. And what that means is during processing, there's a lot of materialization steps that are required. For example, the aggregate hash table that I spoke of before, we have the join hash table, but also for things like the order by, at some point you need to materialize the data, you need to actually go and do the operation, right? Like if you want to sort the data, you don't know what row comes first before you've seen all the data, because there may always be one row that comes before the previous row you've seen. And currently that materialization happens uncompressed, right? Like, so our storage is compressed, but the materializations are not. And while we can offload those to disk for many operators, and soon essentially all operators, having them be uncompressed increases the memory footprint quite significantly. So one thing that we're working on as well, and there's a small demo that we have already available, actually, that's already merged in our feature branch, is compressing those as well. And that allows you to, well, process even larger data sets and keep more data in memory without increasing your memory footprint. So here's an example of how the current version that we have works. Essentially, you can look at like the statistics on top of the data types. And instead of storing the data in the original data type, like let's say you have an int32, a 4-byte integer, if the data is small enough, you can, or like if the difference between the minimum and maximum is small enough, you can end up doing like some frame of reference compression and storing it in a smaller type. And the same can be done with strings. Instead of having these pointers to the strings that end up consuming around 16 bytes per string, you can compress them and actually turn strings into integers, which is kind of cool if they're small enough. And using this, you can quite drastically reduce the size of these materializations for essentially no cost as well. That's also important, that this doesn't actually end up increasing the runtime. Yeah, something that's very cool that we've been working on actually as part of our project with relational AI is support for Apache Iceberg. So if you've been to the conference, you've heard a lot of talks about Delta. Delta is, of course, very cool as well. But Iceberg is very similar. It's a very cool lakehouse format, and something that we have seen more and more traction of, more and more people working on. And we've been working on an extension that allows integration with Apache Iceberg in DuckDB. And currently, that's only with read support. We're planning to add write support later. And we are going to be open sourcing this and pushing this as part of our version 0.9 release as well. And something that's quite cool about Iceberg, if you're using it, is you can do things like time travel. So you can look back at previous version of data sets, which turns out to be quite useful if you want to, for example, undo disastrous deletes. It ends up being quite problematic if you have GDPR requests, but that is not our problem. Yeah. So Iceberg, very cool. Another feature or set of features we've been working on is better integration with data platforms. We see a lot of people that are using DuckDB with our S3 integration, of course, with our HTTP integration. We have some support for Azure, but kind of only in Python. And we have been working on native integration with these platforms and better integration with these platforms. So we're working on an extension that allows you to read and write data from Azure, similar to our S3 connector. That's also in collaboration with Relational AI, actually. And we're working on an extension that allows you to use the AWS supply chain for easier authentication and essentially just making this easier to use. That's going to be very cool as well. All right, cool. So that was a bit of a sneak preview. It's not everything that's going to be in version 0.9, of course, but it's like what I think is, as of now, the coolest features. It's scheduled for around September, so we're all on some summer breaks, so we're going to be pushing it back by a few weeks because of that. But yeah, should be plenty of cool stuff to come. And of course, if you, once the stuff is finished, we do publish pre-release versions, and we always greatly appreciate if people play around with that stuff because, for example, for the pivot operator, there were a lot of people that ended up using this before we actually released it and ended up finding certain problems with it, not big problems, but like small issues that could have been improved. And it's always great if the earlier you find these things, the better, right? So it is greatly appreciated. And of course, that does allow you to use the cutting edge as well. All right, so adoption, has also been a sort of tradition. You can see there's sort of like this effect where we every year put the previous year slide in, so you get a sort of a interesting visual effect. And it's also nice to compare, although you can't read the smaller slides, especially the one that's like inside the one that's inside the one. I can't read them here either. But yeah, so adoption has been quite nice. Our Python installations, that's still one of our, most important, one of our large clients. We get currently around 1.3 million installations per month, which is, I think, somewhat unreal even. Java, we had a data issue in Maven, so we couldn't see the adoption there, unfortunately. But in the last, in February, we had around 600K installations per month, so also very widely used client. A lot of people, I think, use it with things like dbeaver, or of course, if their own stack is written in Java, so it's also very cool. Node.js client also increasing a lot. And there's also a lot of stuff we don't measure, like the direct downloads, people that compile from source themselves, the DuckDB WASM stuff, which is also very, very nice. And 10K GitHub stars, that was a big milestone that we reached a few weeks back, I want to say, a month back, sort of something like that. That was something that we were super happy with, something we, definitely, we expected, of course, before, but not something we expected when we started the project that we would reach this level. And also something that we have now started to track the extension installs, and it's also super cool because somehow we have like 1 million extension installs per month. Mostly the HTTPFS extension, but also the other extensions are quite well used, so that's also very cool. And of course, the website also gets quite some visitors, so yeah, happy to see that, of course. And here's actually some pictures of us at our office celebrating the 10K's GitHub stars. And we actually made a big print out, you can see it in the back, of every single person that started our repository. So of course, I hope you were all present on that list. And we had a 10K stars balloon. So that's, we were quite happy to reach that milestone, of course. Excellent. All right, so, thank you very much for listening to the State of the Duck, and I'd be happy to answer any questions you guys have. I don't know how much time I have. Yes. Mm-hmm. That's actually something that's in our future plans, is to add support. Oh, sorry? Oh, yeah, sorry. For out-of-core aggregates, if the data is sorted, you have to keep very little state. That's very true. We don't currently yet optimize for data that is already sorted, but it's something that we are quite actively looking at for different purposes, right? Like if the data is sorted, you can do some very cool optimizations that we definitely want to pursue more. Yes? Really? So the question was, do you have anything coming for Parquet performance? We have actually been looking at the write performance quite a lot. There's still some wins there. For reading, I think something that we have been wanting to do is making a bit more use of the statistics in the Parquet files. But I think at some point you also hit the limits of the format, of course. I think there's maybe some more optimizations to be done, but we have profiled this somewhat extensively. I think there's still like one thing that's somewhat missing is that our reader currently only parallelizes over the row groups. And there are some writers who will not be named who make very, very large row groups, which is something that is not really what Parquet is meant for, but they do it anyway. And that's something that we could look into improving our support for, like reading one big row group essentially. Yes.
On DuckDB tables already, and then the Iceberg update, you all have a migrations plan on how to take my stuff instead into Iceberg.
So the question is, how do you take your DuckDB table into Iceberg? So I think they are somewhat orthogonal formats in the sense that Iceberg is super cool, of course, but we're not switching away from the DuckDB storage to Iceberg. So I think Iceberg, it is really this cloud native sort of format, right? Like if you are running on your local computer, Iceberg introduces a lot of overheads that you may not really want to deal with. Like it is not it's just not as efficient, but it's kind of like it's doing all these things in order to be compatible with things like S3, with the object stores, right? So it is kind of like an orthogonal thing. It's kind of similar to what I showed before on the pluggable databases. Iceberg will be eventually another type of database you can choose to create, you can choose to query. It won't replace our own storage. We will probably add better support for converting data from one to the other. So currently we have this export and import workflow. We want to add like a direct copy that will simplify these things for sure as well. Yeah. Oh, yeah, time. Sorry. Thank you very much, everyone.